This webinar is to show how to set up the 945U-E Ethernet modem for a bridge network. An example of a bridge network is in this diagram here, where we have a computer connected to an ELPRO 945U-E Ethernet modem, traveling a distance of up to 9 miles to a remote site that has a PLC. So for example, this would be mimicking if we could take this blue Ethernet cable and run it this entire distance and connect it directly into the computer. However, in this example, there is too much distance for that to be practical, or the machinery is moving, or simply for cost reasons, it's simply far too expensive to trench and cable a Ethernet wire. So in this case, we are going to use ELPRO's industrial-grade Ethernet modems to bridge the gap. So what I'm going to do is I'll show you how to set these radios up so that these two networks that are on the same subnet can both communicate with each other wirelessly. The first step to do that is to run a browser such as Firefox. Then in Firefox, we need to type in the IP address of the radio system. The IP address of the radio system is printed on the reverse label, and it is labeled Setup IP Address. When you first log on, you'll receive this security risk warning. Click Advanced to proceed. Scroll down further and then select Accept the risk and continue. The radio has a login system that requires a user and a password. The default for these are user and user, all lowercase. And presto, the configuration menu for the 945 pops up. Now, if you have forgotten what this IP address is, or you have programmed it to a different IP address, there is a backdoor method of entering the radio system. In this slide here, I'm showing a photograph of the bottom panel of the 945U-E. There is a dip switch that has positions of run or setup. If you set the radio to run mode, it will be accessed via whatever IP address you have programmed it with. If you set this dip switch to the setup position and then cycle power on the radio, it will boot up with the setup IP address. The setup IP address is printed on the rear label towards the bottom. It is circled in blue here. In this case, the setup IP address for this modem is 192.168.0.135. Knowing that information, I can always log into this modem even if I don't know what it was configured as. Once we have entered the main configuration menu of the radio, we can go to the Quick Start menu here. The Quick Start menu allows us to very quickly set up the radio encryption, the operating mode, the IP address, everything you made to quickly bridge two radios. We have two operating modes. We either have access point or client, sometimes called station mode. In this case, I'll set this radio to function as the access point. I will leave the IP address set to the factory default. Then we have the SSID of the radio system. The SSID is just what you see on your phone or tablet when you're logging into a Wi-Fi system. You'll see the names of different SSIDs. This is the system address of radios that are within range. In this case, I'm going to make the SSID ELPRO _945. Then we have encryption. We have a variety of types of encryption here. I'll set this one to WPA2-PSK AES. That is the most advanced encryption level available today. I'm going to leave the passphrase with our default of passphrase. Once I'm complete, I hit Save Changes. It's important that you click Save Changes before moving on to any of these other tabs. Otherwise, all information that you've made here will be lost. Then I can have a look at the network settings. I have some other options here, and we have bridge versus router mode. In our case, because the two networks are on the same subnet, we will use bridge mode. In bridge mode, there is only a single IP address, this one right here, that is assigned to both the Ethernet port and the radio port. This makes life a little bit simpler. Okay, and then all we have to do now is just hit Save Changes and Reset. Observing the power LED, you can see that it is now cycling green and red. In the meantime, I'm going to unplug my Ethernet cable from the first radio and plug it into the Ethernet port of the second radio. I'm going to open up a new tab and type in the IP address of that second radio. It is 192.168.0.162. Again, we see the same warnings, so click Advance. Then scroll down and accept the risk and continue. We then have to sign in with our default user and password of user and user. Okay, we have now booted up, and this information here tells us the dip switch status. So this radio is in run mode and can communicate with opposite radios. Note that if the radio is in setup mode, the radio circuit board is powered off, but the motherboard is powered on. Therefore, no radio communications are possible, nor is any connectivity information available unless the radio is set to run mode on boot. So to establish a quick link, we hit Quick Start. The other radio is set as an access point, so I will leave this one as a client. The IP address I will leave as the factory default, since it is on the same subnet as the opposite radio and of the Ethernet port of this computer. The SSID must be the same for all radios in the network. So we're going to change that to ELPRO _945 to match the access point. Lastly, we need to enable the encryption type and make sure this passphrase matches what is in the opposite radio. Then we can hit Save Changes, and we can just go ahead and hit Save Changes and Reset. The radio takes approximately 75 seconds to reboot, and once it is finished rebooting, we will then be observing the TX link LED on the front panel of the radio. When that link LED turns solid green, occasionally flickering when the radio transmits, but when it turns solid in color, that's when we have a radio link between the two devices. I can see my LAN port of my radio I've programmed has booted up already. We're just waiting for the rest of the radio to boot up. And then we can check the connectivity between these two devices and have a look at the signal strength. Okay, the radio has finished booting up. So we're going to click up here And we're going to go back into the main menu here. Okay. Now, to check what the received signal strength is between the two radios, we click on Connectivity. This is now showing us that the RSSI, or received signal strength, is negative 37 dBm. The desired signal strength is between negative 45 and negative 75. The radios will work with signal strengths that are outside of that range. As we can see, it is linked up. However, throughput will be lower because of either saturation, if the signal is too strong, or simply weak signal, causing signal not strong enough, causing the throughput to be lower. The other information that we see here is we see the MAC address of the opposite radio. We see the IP address of the opposite radio. This is a unique address that is assigned to each remote site, and it just increments up from 1. This tells us the frequency channel. This radio is set to channel number 15. This tells us the current data rate that this radio link is establishing, which is 3 megabits per second. The data rate is a bit on the low side for what I would expect. However, this is because the RSSI is too strong. Now, these radios are approximately 6 inches apart, but they do have 20 dB attenuators on each radio. If we did not have those attenuators, it's likely the radios would not link up because the signal strength would be far too strong even for a basic radio link. BGND is telling us what the background noise level is. In this case, the background noise level is negative 100 or negative 99, which generally is at the threshold of reception for these radios. So we could say effectively there is no interference. Because we are logged into a client radio, this shows us the information from the access point radio. It is using SSID ELPRO _945. This is the MAC address of it, the frequency channel. The rate appears to be slightly different. That is the maximum possible rate for the channel width that we have selected. This is showing the signal to noise ratio. Our signal is negative 37, and the background noise is negative 99.